All right, in this video lecture, I'm going to do a worked example of 13:16, where we're being asked to first decide if the argument is valid. If the argument is valid, then we'll do a proof in Fitch. If it's not valid, then we need to provide a counterexample in Tarski's world. So let's first make sure that we understand what the argument is saying. First premise says that there exists an x, there exists a y, and x adjoins y. Now, if we think about whether x and y have to be two distinct objects, we don't see anything about an identity claim. So for all we know so far, the x and y could actually be the same object. The second thing we can look at is whether adjoining requires that x and y be distinct. So do you adjoin yourself? If we look back at the Tarski world definitions, the definition for adjoins is that there are going to be two distinct objects that are beside each other in Tarski's world. So we know that x and y are going to be distinct objects. Then we look at the second part, right, the second premise. It's saying for all x and for all y, if x adjoins y, so for any objects that adjoin each other, then it's not the case that x and y are the same size. So what 2 is intuitively saying is that all two objects that adjoin each other are going to be different sizes. And then in the conclusion, we have the claim that there exists an x and there exists a y, such that it's not the case that y is the same size as x. So it seems like the object that satisfies, or the two objects that satisfy this first premise, will then have to obey this rule that is specified in the second premise, which means that they can't be the same size. Right? So it looks, at least on first brief sort of gloss, that this looks like a valid argument. So if it is a valid argument, we should be able to do a proof of it. So let's go over into Fetch and see if we can't develop a proof of it. So I've got opened here 13:16. I'm gonna make this a little bit smaller so we can see the entirety of this with the goal. Okay, what I'm gonna do is first give my proof steps numbers, just makes it a little bit easier to refer back to the various steps that are being justified without having to click on the particular link. And I'm going to right away add in my goal. The way I'm going to do that is actually just copy and paste the goal into that line. And then what I'm going to do is start thinking about various proof strategies that I might be able to use. Now, just like with proof by cases, which was the disjunction elimination, one of the strategies that you'll use is if you see an existential claim in one of your premises, you should think right away, okay, I need to do existential elimination. And existential elimination requires a subproof. So here what I'll do is I'll start a subproof where I'm going to call a certain object, the object that satisfies the x position here, right, where it adjoins y. I'm going to call that A. So I can write this out as, I'm going to do this the long way first. Sorry. Do this. Adjoins A, Y. And my goal in this subproof is, again, to get to the this conclusion. What I'm trying to do is say, okay, if I call this thing X, if I call that A, and then I can get to the claim that there exists an X, there exists a Y, such that Y is not the same size as X, then I can discharge the assumption that I had made earlier that X was called A. So the rule I'm going to use is existential elimination. I have this subproof, and this subproof is sort of kicked off by 1. So what I'm doing is saying, okay, I'm going to temporarily give X a name. That's what I've done with assumption 3. Once I've gotten to the sub-conclusion here, I'm going to say, okay, now I'm going to get rid of that assumption that I had called X and A, right? So that's why I see the conclusion here written twice, right? Once at the end of the subproof in line 5, and then once again on line 6, right? So this is what's similar to the proof by cases is in each of the subproofs, if I get to the same conclusion, I can pull that conclusion out onto the main line of the proof. So that's why you end up seeing that conclusion here twice. Okay, so again, I have this this assumption that has an existential claim in it. So I'm going to again do an existential elimination proof. So I need to have another subproof where this time I'm going to say, okay, let me call Y some name. Let me call it, and this is important, it has to be something that hasn't yet appeared. So I'm going to do a joins AB, and my goal here is going to again be the same goal that I have in 7. I'm going to try to establish that there exists an X, there exists a Y, such that Y and X are not the same size. Here, my elimination rule is again going to be existential elimination. And what I'm doing here is eliminating the assumption I had made that B was the name that I was using for Y. And what kicked this one off was the fact that in 3, I started with an existential claim. And that will check out. So I'm hoping what you're seeing here, right, is every time you have an existential claim as an assumption, right, you want to temporarily give one of the variables a name. And here I'm doing that one at a time. And then once I have a conclusion, then I can discharge that assumption of the name that I used, right? It's saying, oh, okay, I used B temporarily, but now let's go back to let's go back and discharge that assumption, right? I'm just gonna I'm gonna take away that assumption at this point. Man, it's been a long day, sorry. Okay, so that's why here you're gonna see, right, the conclusion written 3 times now, but each time, right, from going from 6 to 7, it's saying, oh, okay, I'm going to no longer make the assumption that B was the thing that I was using the name B. And then from 7 to 8 is where I'm saying, okay, I no longer need to keep hold of the fact that I called X A. Okay, so now once I'm inside this subproof, right, I'm trying to figure out how do I get from the claim that A adjoins B to the claim that there exists an X and there exists a Y such that they're not the same size. Well, I've been making use of the existentially quantified sentences. What I haven't made use of yet is the universally quantified sentence. And here, right, you'll notice that, oh, wait a minute, if I can satisfy this antecedent in here, then I can get the consequent. But this is not a conditional statement. 2 is actually a universally quantified statement. So I need to do universal elimination on this. So if I do universal elimination on 2, I would have for all Y, because I'm going to get rid of the universal quantifier that's binding X first, adjoins, and I'm going to replace X with some name. And here I no longer have the restriction that I can't pick something that has already appeared. I'm allowed to name X whatever I want. And so I'm going to sort of be a little bit smart about this. I'm going to try to insert names to be able to match patterns that already exist. So with 4, I noticed that A adjoins B. So what I'm going to do is replace X with A, and I'll still have that Y, right? Because all I'm doing is I'm doing this one step at a time. I'm only replacing the universal universally quantifier that was binding X. So I'm going to have A adjoins Y, then not same size A Y. I'm going to close that. So I'm going to cite line 2, and that's going to be universal elimination, and that checks out. And now I'm going to apply another instance of universal elimination on 5. So this time I'm going to take the variable y and replace it with a name. And again, this time I don't have the restriction of not using a name that hasn't been used before, because I'm using universal elimination. I get to pick whatever name I want. So here I'm going to be smart again. I'm going to try to use a name that is going to help me match certain patterns. And in particular, I want to use B. So I'm going to say adjoins AB, then not same size AB. Oh, I haven't specified the rule yet, but this is universal elimination, setting line 5. Okay, so now you'll notice that I have the antecedent in 6. So 6 says if A adjoins B, then it's not the case that A is the same size as B. I have the antecedent for that written in 4, so I can actually just use the conditional elimination rule to write down not same size A, B. And that follows from A4 and 6. And that is the conditional elimination rule. And now once I have number 7, I can see that, oh, I can actually replace, or if A is not the same size as B, then there is something that is not the same size as B. In fact, even further, I can say there exists something that is not the same size as something. So we might see if we can actually introduce the variables, both variables at the same time. And you'll notice that, in fact, Fitch lets you do this so long as there isn't an in-between universal quantifier. It's saying, okay, I'm going to let you skip like the 2 additional steps. Okay, so now we've gotten to all of these steps checked out along the way. So if I click this button to make sure that all the checks step out, they in fact do. And so that's showing you how to do 1316.